So good afternoon, everyone. So my name is Sampath Kumar CM from Maglur Basava PU College. So today we'll start with one more chapter in organic chemistry, that is aldehydes, ketones, and as well as carboxylic acids. So let us start with aldehydes, ketones, and as well as carboxylic acids. So here, actually, compared to all other chapter, this one is a little bit bigger chapter, and it contain more number of organic chemical reactions. So in this particular chapter, so majorly we are going to deals with IUPAC nomenclature. So preparation and as well as preparations and one more chemical property and physical property. So IUPAC nomenclature, preparation, physical property, and one more chemical property. And so we are going to discuss some named reaction which is comes under preparation and as well as chemical property. So let us start with a small recap regarding IUPAC nomenclature. I think you already know about IUPAC nomenclature. Already you discussed. So here the must and should we know this particular formula, that is a root word. So the root word should be followed with so primary suffix, and just a primary suffix should be followed with secondary suffix, and another one primary prefix, and another one is secondary prefix. So actually this one is a main formula which is used to write IUPAC nomenclature for any organic compound. So it's just a small recap regarding IUPAC nomenclature. Just we can consider a simple component like a CH3 and as well as CHO. We already know that here whatever the functional groups are there, carbonyl containing compounds such as. So we can consider first one as CHO, another one is CO, another one is COOH. So here if you observe these three components, this one is considered as an aldehyde, and this one is considered as a ketone, and another one is considered as a carboxylic acid. We already know that. So among these three, the common group what we are observing, that is a C double bond O. This particular group is common for all. So both aldehydes, ketones, and as well as carboxylic acids. So ಈಗ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ನೋಡಿದ್ರೆ ಇದರಲ್ಲೂ ಕೂಡ ಸಿ ಡಬಲ್ ಬಾಂಡ್, here also C double bond, here also what C double bond O. So each and every component they always contain carbonyl. So that's why we can consider that these are all compounds are carbonyl compounds. So when we comes under IUPAC nomenclature, compulsory if anything contain aldehyde as a functional group organic compound, then we have to use a secondary suffix as Al, and ketone is nothing but ONE, and carboxylic acid is nothing but OIC acid. This one you already discussed in first chapter in organic chemistry. So let us start with this particular component here, CH3CHO. Name of this compound is also called as what? Two carbon atoms are there. Root word is taken as eth. So it contains single bond. That's why we have to write ANE, and E should be cancelled here. So then ethane, E should be cancelled. Then finally we can write here Al. So name of this compound is called as what? Ethanol. So if it contain one more component also, CH3, CH2, CH2, CHO. So name of this component is also called as here. How many number of carbon atoms are there? 1, 2, 3, and as well as 4 carbon atoms. That's why here we can write a butane 1-ol. So in the same way, we can consider another component also, CH3, CH2, C double bond O, CH3. Here we are taken a ketone as a functional group. So the position what we are observing 1, 2, 3, and as well as 4. Name of this particular compound is taken as 2-butanone, otherwise butane 2-1. So these are the common things what we are going to discuss in IUPAC nomenclature. So ಇವೆಲ್ಲ ಕೂಡ ಗೊತ್ತಿರೋದೆ common thing. So we can take one more example also, CH3, CH2, CH2, COOH. So if you observe this particular component, so in this component also contain one functional group that is act as a carboxylic acid. So carboxylic acid itself contain a carbon. So that's why we can consider this particular functional group as a terminal functional group. So if any terminal functional groups are there, compulsory we have to choose a carbon which is present in functional group. Then here this one is act as a parent chain. So here 1, 2, 3 and as well as 4. So then name of this compound is but. Root word is taken as but and primary suffix what we are using an, and the position of functional group is 1, oic acid. Otherwise this one is also called as a butanoic acid. So one more. So by using these are all things we can easily write IUPAC nomenclature. But when it comes under common name, so the common name, this particular component, if you use CH3, if we consider common name for different components, CH3, CHO, another one CH3, CH2, CHO. So another one what we are observing HCHO. If you observe name of common name of this particular component is also called as formaldehyde. CH3, CHO. So we can consider here HCHO is nothing but formaldehyde. That is formaldehyde. That's a common name. This one is acetaldehyde. So this one is propanaldehyde. So if it contain 4 carbon atom also, that is a butyraldehyde, like that, we can give common name for different organic compound which contain aldehyde as a functional group. So then, so if it contain ketone, otherwise any other substituents are there, like CH3, CH2, CHO. In any substituents are there, then compulsory the position of substituent can be indicated by using some of the prefixes like alpha, beta, gamma, delta. Right. So we can consider alpha, beta, gamma, delta, etc. So in IUPAC nomenclature, compulsory we are using the numbers to mention the position of substituent. But ಆದ್ರೆ ಇಲ್ಲಿ ಫಾರ್ಮ್ ಇಲ್ಲಿ ನಾರ್ಮಲಿ ನೀವು ಆಲ್ಡಿಹೈಡ್ ಅದರ್ವೈಸ್ ಕೀಟೋನ್ ಯಾವ್ದಾರ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ರಪ್ಪ. Position mention ಮಾಡ್ಬೇಕಂದ್ರೆ in common name compulsory we have to use alpha, beta, gamma and as well as delta. Suppose if substituent is present here, the substituent is present in second position. So third position, if you observe now, this is functional group. Next to functional group, the position is taken as alpha. Next to alpha is taken as what? Beta. So here substituent is present in beta position. So that's why the common name what we are going to use. So beta methyl. So total number of carbon atom is taken as 4 carbon atoms are there, 1, 2, 3, 4. So that's why we have to use butyraldehyde. So these are all the way we are using different methods to name a common name of any organic compounds. Let's move on to the most important one, structure of carbonyl group. So why it is important to understand structure of a carbonyl group? Because based on that only we are going to explain the complete reactivity of both aldehydes and as well as ketones, and one more. So the solubility and polarity of aldehydes and ketones also. So structure of carbonyl, we already know that the structure of carbonyl, what we are observing, C double bond O. So carbon contain here total 3 sigma bonds are there. Common thing is this one is undergo sp2 hybridization. So here what happens among carbon as well as oxygen will be more electronegative in nature. That's why oxygen will get a negative charge and carbon will get a positive charge. So due to this transfer of a pi electron, so it develop a polarity C single bond O minus and as well as plus here. So carbon will get positive charge and oxygen will get a negative charge. So due to this charge separation, there is a polarity will be developed between carbon as well as oxygen. So due to this polarity, so I think already we know that the polarity is nothing but a charge separation. Due to this polarity, so definitely what happens, they will develop one particular interaction. That interaction is also called as a dipole-dipole interaction. So any compound which show polarity, definitely those components having a dipole moment. So here, due to this polarity, so they will develop a dipole-dipole interaction. So due to the dipole interaction, respective other hydrocarbons, carbonyl compounds having a carbonyl compounds having high melting point and as well as boiling. So is everything is completely dependent on polarity. So here what happens, so whatever the carbonyl compounds are, either it may be aldehyde, otherwise ketones, there is a polarity will be developed between so carbon and as well as oxygen. Due to this polarity, so they will develop one separate interaction. That interaction is called as what? A dipole-dipole interaction. So to break this dipole interaction, compulsory required extra amount of temperature. That's why melting point and as well as boiling point will be increases for these carbonyl compounds like aldehydes and as well as ketones. So then after discussing this structure of carbonyl group, let's move on to one more. Directly we move on to preparations. So let us start with the preparation of aldehydes and as well as ketones. If you consider, there are a number of ways are there to prepare aldehydes and as well as ketone. If you consider first one, by using so by using, normally we know that so whatever the aldehydes and as well as ketones are there, so we can able to prepare by using an oxidation method. Otherwise, by using an alcohol, we can able to prepare aldehydes and as well as ketones by using alcohol. So how we can able to prepare aldehydes and as well as ketones by using an alcohol? Generally, we know that already you discussed in alcohol phenols and as well as carboxylic acid. So the first one is by oxidation of alcohol. So to undergo oxidation, compulsory here we have to use certain reagents. There are number of reagents are there to prepare aldehydes, ketone, and carboxylic acids by using an alcohols. Normally, there are two types of reagents as oxidizing reagents are there. One is a mild oxidizing agent. So mild oxidizing agent. Another one what we are observing, that is a strong oxidizing agent. ಕೆಲವೊಂದು ಮೈಲ್ಡ್ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗಿರುತ್ತೆ, ಕೆಲವೊಂದು ಸ್ಟ್ರಾಂಗ್ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್. ಇದು ಕನ್ಫ್ಯೂಷನ್ ಬೇಡ. ಯಾಕೆ ಅದನ್ನ ಮೈಲ್ಡ್ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ ಅಂತ ಕರೀತಾರೆ, ಯಾಕೆ ಅದನ್ನ ಸ್ಟ್ರಾಂಗ್ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್? ಸೊ ಈಗ ನೋಡು, ನಾವು ಪ್ರಿಪೇರ್ ಮಾಡ್ಬೇಕಾರದೇನು, ಸೊ ವಿ ಹ್ಯಾವ್ ಟು ಪ್ರಿಪೇರ್ ಆಲ್ಡಿಹೈಡ್ಸ್ ಅಂಡ್ ಆಸ್ ವೆಲ್ ಆಸ್ ಕೀಟೋನ್ಸ್. ಸೊ ಆಕ್ಸಿಡೇಷನ್ ಅಂದ್ರೆ ನಾರ್ಮಲಿ ಆಲ್ಕೋಹಾಲ್ ಏನಾಗುತ್ತೆ, ಆಕ್ಸಿಡೇಷನ್ ಆಗಿ ದೇ ಕ್ಯಾನ್ ಕನ್ವರ್ಟ್ ಇನ್ ಟು ಆಲ್ಡಿಹೈಡ್, ಅದರ್ವೈಸ್ ವಾಟ್ ಕೀಟೋನ್ಸ್. So if you use strong oxidizing agent, they undergo further oxidation. ಮತ್ತೆ further oxidation ಆಗಿ ಏನಾಗಿ ಕನ್ವರ್ಟ್ ಆಗ್ಬೋದು, they may be continuously undergo oxidation to form carboxylic acids. So ನಮ್ಮ intention ಏನಂದ್ರೆ, we need to prepare only aldehydes and as well as ketones. So that's why compulsory we have to use a mild oxidizing agent. So mild is nothing but what? Just stop oxidation up to aldehydes and as well as ketones. Strong use ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? They never stop up to aldehyde and as well as ketones. Further oxidation ಆಗಿ ಏನಾಗಿ convert ಆಗುತ್ತೆ? Carboxylic acids. So let us discuss what are the different mild oxidizing agent and as well as strong oxidizing agent. I think ಇದನ್ನು ಕೂಡ alcohol phenols discuss ಮಾಡಿರ್ತೀರ. So normally we can use so chromium trioxide, we already know that chromium trioxide in pyridine. So another component we already know that is either we can use PCC, otherwise what? A PDC. So these are all considered as what? A mild oxidizing agent. But when we comes under strong oxidizing agent, the strong oxidizing agent already we know that that is acidic KMnO4, otherwise K2Cr2O7. So acidic KNMNO4. Otherwise we can use acidic K2Cr2O7. So normally what happens, these are all strong oxidizing agent. They can able to convert alcohol into a carboxylic acid. They never stop up to aldehyde, otherwise ketones. That means to prepare aldehyde and ketone, compulsory we have to use a mild oxidizing agent. So let us know how these are undergo oxidation. So by using an alcohol, we can take one simple example. CH3, CH2, CH2OH. So ನಿಮಗೆ ಗೊತ್ತಿಲ್ಲಪ್ಪ ಆಲ್ಕೋಹಾಲ್ ಆಕ್ಸಿಡೇಷನ್ ಆಗ್ಬೇಕಂದ್ರೆ ಸೊ ಕಂಪಲ್ಸರಿ ಇಟ್ ಶುಡ್ ಕಂಟೈನ್ ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್. ವಿತೌಟ್ ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಇಟ್ ನೆವರ್ ಅಂಡರ್ಗೋ ವಾಟ್ ಆಕ್ಸಿಡೇಷನ್. ಸೊ ಆಕ್ಸಿಡೇಷನ್ ಆಗ್ಬೇಕಂದ್ರೆ ಕಂಪಲ್ಸರಿ ಅದರಲ್ಲಿ ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಇರಲೇಬೇಕು. ಇಫ್ ಯು ಅಬ್ಸರ್ವ್ ನೌ, this is a functional group. Functional group containing carbon atom is called as what? Alpha. Next to alpha is considered as what? Beta. We already know that. So when this one is undergo oxidation, so oxidation ಆಗ್ತಿದೆ ಅಂತಂದ್ರೆ in the presence of either we can use PCC, otherwise PDC. So ಇಲ್ಲಿ observe ಮಾಡಿ ನೋಡಪ್ಪ. So we can write this one separately. ನಿಮಗೆ ಅದನ್ನ ಯಾವ ತರ ಬ್ರೇಕ್ ಆಗುತ್ತೆ ಅಂತ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಂದ್ರೆ. So here we can consider one hydrogen, alpha hydrogen atom. So hydrogen, oxygen and hydrogen, they completely removed as water molecule. Then finally we are able to get CH3, CH2, C double bond OH. So the name of this compound is called as what? Propanaldehyde, otherwise propane 1-ol. So observe carefully. So hydrogen atom which is present in oxygen and hydrogen atom present in alpha carbon atom along with one oxygen, both are completely removed. So we can able to get aldehyde as a final component. So otherwise we can take one more also like CH3, CH, here it contain one CH3, here it contain one CH3. So if you observe carefully, when this one is undergo oxidation, ಸೊ ನೀನು ಅಬ್ಸರ್ವ್ ಮಾಡಿ ನೋಡಪ್ಪ, ನಾನು ಈಗಿನ ಕೂಡ ಹೇಳಿದೀನಿ ಇಲ್ಲಿ ಆಕ್ಸಿಡೇಷನ್ ಆಗ್ಬೇಕಂದ್ರೆ ಕಂಪಲ್ಸರಿ ನಾ ಏನ್ ಬೇಕು ಅಂತ ಹೇಳಿದೀವಪ್ಪ, ಕಂಪಲ್ಸರಿ ರಿಕ್ವೈರ್ಡ್ an alcohol. So CH3, CH2, here one CH3, here it contain one OH. So normally when this particular component is undergo oxidation, so oxidation ಆದ್ರೆ we already know that when this one is undergo oxidation, compulsory required alpha hydrogen atom. This is OH group. OH group containing carbon is called as what? Alpha. So here one hydrogen, here also it contain one hydrogen. So thereafter oxygen, both are combined together. So then finally we are able to get CH3, another one CH3, CH3. Here we can consider C double bond O. CH3, C double bond O, CH3. If you observe carefully, so in this particular compound, what happens after oxidation? So compulsory secondary alcohol should be converted into what? Ketone. So now only we discussed primary alcohol should be converted into aldehyde, and in the same way, secondary alcohol should be converted into a ketone. And one more important thing is a tertiary alcohol. So this tertiary alcohol never undergo oxidation. So the what is the reason behind that? Tertiary alcohol never contain alpha hydrogen atom. If you observe now, this is OH group. OH group containing carbon is called as alpha carbon atom. This alpha carbon atom does not contain any alpha hydrogen atom. That's why it's never undergo oxidation. So only if you use any other oxidizing agent, maybe possibilities are that they can convert, they undergo what, dehydration, and finally they are converted into what, alkenes. So alkene baro chances ಇದೆ, ಅಲ್ವಾ? So this is a one particular way we can able to convert alcohol into what, aldehydes otherwise ketones. So next, if you use same by using an alcohol, we can use another method that is also called as a dehydrogenation. So normally we know that a dehydrogenation is nothing but removal of hydrogen. So compulsory we have to use reagent. Yav reagent na use ಮಾಡಬೇಕು. The reagent what we are using, copper at nearly about 573 Kelvin temperature. ಈ temperature ನ use ಮಾಡಬೇಕಾಗುತ್ತೆ. So the compulsory here also same. Here also alpha hydrogen atoms are must and should. Without alpha hydrogen atom, alcohol never undergo dehydrogenation. Dehydrogenation is nothing but removal of hydrogen. ಇದು alcohol ಅಲ್ಲಿ discuss ಮಾಡಿದೀಯ. So ಈಗ ಅಬ್ಸರ್ವ್ ಮಾಡೋಣ, CH3 CH2 ಎರಡು ಕಂಟೈನ್ CH2OH. ಸೊ ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ನೋಡಪ್ಪ, OH ಇದೆ, ನೆಕ್ಸ್ಟ್ ಕಾರ್ಬನ್ ಇಸ್ ಆಲ್ಫಾ. ಸೊ ಇದರಲ್ಲಿರೋ ಒಂದು ಹೈಡ್ರೋಜನ್ ತಗೋಣ ಸಪರೇಟ್. CH, here it contain one hydrogen separately. So when addition of copper will take place at 573 Kelvin temperature, then automatically hydrogen is completely removed, and finally we are able to get a CH3 CH2 CHO. So name of this compound is called as what? Propanol. Over. In the same way, we can use secondary alcohol also, CH3 CH2 CHR. Here it contain one CH3, here it contain one OH, here it contain one H. If you observe now, this one is act as a secondary alcohol. So when the secondary alcohol, this is OH group, functional group, next carbon atom is alpha. So alpha carbon atom contain hydrogen. So hydrogen completely removed. And finally, we can able to get another component, CH3, CH2, C double bond O, CH3. So here we can able to get ketone. So very simple explanation. Primary alcohol always gives aldehyde and secondary alcohol gives ketone. Tertiary alcohol never undergo dehydrogenation. Here also same, because it does not contain alpha hydrogen atoms. Over. So after discussing a dehydrogenation, so next, so compulsory we need to understand one more important thing, that is preparation of aldehydes and ketones by using hydrocarbons. ನೋಡೋಣ, ಹೈಡ್ರೋಕಾರ್ಬನ್ಸ್ ನ ಯೂಸ್ ಮಾಡಿ ಹೇಗೆ ಪ್ರಿಪೇರ್ ಮಾಡಬಹುದು, ಇದನ್ನು ಕೂಡ ಡಿಸ್ಕಸ್ ಮಾಡಿರ್ತೀಯ ಫಸ್ಟ್ PUC ಚಾಪ್ಟರ್ಸ್ ಅಲ್ಲೆಲ್ಲ ಕೂಡ. ಸೊ ಫಸ್ಟ್ ಒನ್ ಈಸ್ ಬೈ ಯೂಸಿಂಗ್ ಆಲ್ಕೀನ್ಸ್. ನೋಡೋಣ, ಆಲ್ಕೀನ್ಸ್ ನ ಯೂಸ್ ಮಾಡಿ ಹೇಗೆ ಪ್ರಿಪೇರ್ ಮಾಡ್ಬೇಕಂತ. ಸೊ ನಾರ್ಮಲಿ ವಿ ಆರ್ ಯೂಸಿಂಗ್ ಒನ್ ಆಫ್ ದ ಬೆಸ್ಟ್ ಮೆಥಡ್ ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್, ಓಝೋನೋಲೈಸಿಸ್. Ozonolysis. So here same thing, CH2 double bond CH2. We already know that when we are adding ozone, so compulsory, so it can able to produce a CH, here one O, here one O. When ozone is added to an alkene, we already know that wherever it contains double bond, ozone will, three oxygen atoms will directly attach on that particular position, and compulsory they're going to form one cyclic structure, that is ozonide product, right? So here if you observe carefully, how we can able to write ozonide product, that is CH2. So here we can remove double bond, thereafter here one oxygen, so here it contain one more, here it contain one. So here breaking of bond will take place in the presence of zinc. So there here what happens, CH2O, here we can able to get one product, here also we can able to get one more product, and zinc and as well as oxygen both are combined together to form what, zinc oxide. So here CH2O can also be written as HCHO. CH2O ನ ಇದ್ರೆ ಏನಂತ ಬರೀಬೇಕಾಗುತ್ತೆ ನಾವು, CH2O ಅಂತ ಎಲ್ಲಾರು ಮೆನ್ಷನ್ ಆಗಿದ್ರೆ ಕಂಪಲ್ಸರಿ ವಿ ಹ್ಯಾವ್ ಟು ರೈಟ್ HCHO ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಬೇಕು. ಹಿಯರ್ ವಿ ಕ್ಯಾನ್ ಏಬಲ್ ಟು ಗೆಟ್ HCHO ಅಂಡ್ HCHO 2 ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್ ಬರುತ್ತೆ. 2 ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್ ಬರುತ್ತೆ. ನೋಡೋಣ ಇನ್ನೊಂದು ಕಾಂಪೋನೆಂಟ್ ತಗೊಂಡು. ದಿಸ್ ಒನ್ ಇಸ್ ಸಿಮಿಟ್ರಿಕಲ್ ಆಲ್ಕಿನ್. ವಿ ಕ್ಯಾನ್ ಟೇಕ್ ಅನ್ಸಿಮಿಟ್ರಿಕಲ್ ಆಲ್ಸೋ. ದಟ್ ಈಸ್ CH3 CH double bond CH2. So when this one is undergo ozonolysis, so ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡು, ವೆರೆವರ್ ಇಟ್ ಕಂಟೆಂಟ್ ಡಬಲ್ ಬಾಂಡ್, ಅಲ್ಲಿಗೆ ಏನಾಗಬೇಕು 3 ಆಕ್ಸಿಜನ್ ಆಟಮ್ ಆಡ್ ಹಾಕಬೇಕು. ಫೈನಲಿ ಸೊ ವಿ ಕ್ಯಾನ್ ಏಬಲ್ ಟು ಗೆಟ್ CH3 CH. So here it contains CH2, here 1 oxygen, here also it contain 1, here also it contain 1. So breaking ಆಗೋದಿಲ್ಲ, ಆಗುತ್ತೆ breaking in the presence of what? Same zinc and as well as hydrogen peroxide. So then breaking of bond will takes place. So ಅಲ್ಲಿಗೆ ಏನಾಗುತ್ತೆ ಅಬ್ಸರ್ವ್ ಮಾಡು, we can able to get two different products. One is a CH3CHO, ಇನ್ನೊಂದು ಏನ್ ಬರುತ್ತೆ CH2O. CH2O can also be written as what? HCHO ಅಂತ ಹೇಳ್ತೀವಿ. CH3CHO, name of this compound is called as an acetaldehyde. Another one what we are observing, that is HCHO, that is also called as formaldehyde. One is acetaldehyde, another one is taken as what? Formaldehyde. ಎರಡು ಕಾಂಪೋನೆಂಟ್ ಬರುತ್ತೆ. So but in competitive examination, ozonolysis they will ask in a different way. So by giving two components like HCHO to get 2 formaldehyde. So ಎರಡು formaldehyde ಬರಬೇಕಂದ್ರೆ, so what type of a compound we can able to use? Otherwise the alkene what we are going to use ಅದನ್ನು ಕೂಡ ಕೇಳ್ತಾನಪ್ಪ ರಿವರ್ಸ್ ಆರ್ಡರ್ ಅಲ್ಲಿ. ಈಗ ನಾವೇನ್ ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ ಆಲ್ಕೀನ್ ಇಂದ ಆಲ್ಡಿಹೈಡ್ ಅಂಡ್ ಕೀಟೋನ್ಸ್ ಕನ್ವರ್ಟ್ ಮಾಡಿದೀವಿ. So but sometimes what happens, they will ask in different way. Aldehydes, ketones ಅವನೇ ಕೊಟ್ಟಿರ್ತಾನೆ ಪ್ರಾಡಕ್ಟ್. We need to identify reactant molecules. So then let us know how we can able to identify reactant molecules. So ಐಡೆಂಟಿಫೈ ಮಾಡ್ಬೇಕಂದ್ರೆ ವೆರಿ ಸಿಂಪಲ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್. ಈಗ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಾ ಇದೆಯಾ, ಎಲ್ಲಿ ಡಬಲ್ ಬಾಂಡ್ ಇತ್ತು ಆ ಡಬಲ್ ಬಾಂಡ್ ಜಾಗಕ್ಕೆ ಏನಾಗಿದೆಯಪ್ಪ 2 ಆಕ್ಸಿಜನ್ ಆಟಮ್ ಆಡ್ ಆಗ್ತಿದೆ, ರೈಟ್? ಸೊ ದಟ್ಸ್ ವೈ ವಿ ಕ್ಯಾನ್ ಕನ್ಸಿಡರ್ HC ಡಬಲ್ ಬಾಂಡ್ OH. ಇದು ಎರಡು ಕೂಡ ಸಪರೇಟ್ ಬರ್ಕೊಳ್ಳೋಣ. ಸೊ ಹಿಯರ್ ವಿ ಕ್ಯಾನ್ ಟೇಕ್ ಒನ್ ಮೋರ್ ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್, ದಟ್ ಈಸ್ HCHO. C double bond O. ನೋಡು ವೆರಿ ಸಿಂಪಲ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್. ಆಲ್ಡಿಹೈಡ್ ಏನಿದೆ ಕಾರ್ಬನಿಲ್ ಗ್ರೂಪ್, ಈ ಸಿ ಡಬಲ್ ಬಾಂಡ್ ಎರಡೂ ಏನ್ ಮಾಡ್ಬೇಕು, ಓಪನ್ ಬರ್ಕೋಬೇಕು. ಸೊ ದೆನ್ ಸೊ whatever the 2 oxygen atoms are, just remove these 2 oxygen atoms. Instead of these 2 oxygen atoms, just add double bonds. Then finally we are able to get a CH2 double bond CH2. ನೀನು ಯಾವ ತರ ತಗೊಳಪ್ಪ, otherwise we can consider one more example also. To get 2 moles of acetaldehyde, ಎರಡು ಅಸಿಟಾಲ್ಡಿಹೈಡ್ ಬರ್ಬೇಕಂದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು, we can consider here acetaldehyde formula, that is CH3 C double bond OH. ಇದು ಅಸಿಟಾಲ್ಡಿಹೈಡ್. 2 moles ಬರ್ಬೇಕಂದ್ರೆ we can take one more also, CH3. Here it contain double bond OH. ನಮಗೆ ಯಾವಾಗಲೂ ಇನ್ಫಾರ್ಮೇಶನ್ ಮಾಡ್ದಂಗೆ, wherever it contain double bond we are adding 2 oxygen atoms. That's why just remove these 2 oxygen atoms. Instead of the 2 oxygen atom, just add 1 double bond. Then finally the answer may be CH3 CH double bond CH. It contain one more component as CH3. Name of this compound is called as butadiene. If you use this particular component, so definitely we are getting 2 moles of acetaldehyde. So this is one more important information regarding reverse of an ozonolysis, right? So reactant ne yav riti find out ಮಾಡ್ಬೇಕಂತ. So next move on to another preparation of aldehydes and ketones by using a hydrocarbon, that is by using alkynes. So compulsory here we have to use hydration of alkynes can be carried out. The reagent what we are going to observe, reagent ಏನು ಯೂಸ್ ಮಾಡಬೇಕು, reagent So HgSO4 mercuric sulfate along with an H2SO4, dilute H2SO4. Otherwise, this one can also be written as Hg plus 2 and as well as H plus. So this one is very important reagent which can able to convert an alkynes into aldehyde, otherwise in ketones. So we can take two types of an alkynes are there here. We already know that symmetrical alkynes and as well as unsymmetrical alkynes. Symmetrical alkyne, otherwise we can consider one more unsymmetrical. Unsymmetrical alkynes. If we consider symmetrical alkynes, such as CH triple bond CH, symmetrical alkynes. So addition of water molecule will takes place in the presence of reagent as Hg plus 2 and as well as H plus. So initially what happens, water molecule, this one is undergo dissociation as H plus and as well as OH minus. So nodappa, shifting of component will takes place, bond minus ಬರುತ್ತೆ ಇಲ್ಲಿ ಏನ್ ಬರುತ್ತೆ plus ನೋಡಪ್ಪ, this is not a mechanism, is a simple way to understand how H plus and OH minus water molecule is added to alkynes. So here for this minus, so here we can add H plus, for OH minus here we can add for C plus. Then finally we are able to get CH, here it contain OH, double bond CH2 ಬರುತ್ತೆ. So when alkyne is undergo hydration, compulsory we can able to get enol. Enol is nothing but double bond containing carbon atom having OH group. That is called as what? Enol. So when this enol, we already know that enol easily undergo tautomerism. Let us know how this one is undergo tautomerism. So tautomerism ಆಗ್ಬೇಕಂದ್ರೆ compulsory the carbon atom which contain OH group, the same carbon atom should contain what? Double bond. Then only that one is undergo ozonolysis. Then so here this one is removed as H plus. ಗೊತ್ತಿದೆ ಅಂತ ಅನ್ಕೊಳ್ತೀನಿ ozonolysis ಹೇಗಾಗುತ್ತೆ ಅಂತ ಹೇಳಿ. So we can take a small explanation regarding ozonolysis. Just observe carefully that enol form. So enol, this can also be written as CH, here it contain OH, here it contain double bond, CH2. So to undergo tautomerism, compulsory, this one is removed as H plus ion. This bond is shifted to here, we can able to get minus and as well as plus. So here to satisfy these positive, we are shifting this bond to here. Then finally, H plus is directly attached to CH2. So ಯಾವ ರೀತಿ ಅಡಕಾಗುತ್ತೆ ಅಂತ ಅಬ್ಸರ್ವ್ ಮಾಡಪ್ಪ. ಸೊ ಫಸ್ಟ್ ಏನ್ ಮಾಡ್ತೀವಿ ನಾವು H ಪ್ಲಸ್ ಏನ್ ರಿಮೂವ್ ಮಾಡ್ತೀವಿ, ಈ ಬಾಂಡ್ ಈ ಕಡೆ ಶಿಫ್ಟ್ ಮಾಡಿ ಏನ್ ಬರುತ್ತೆ ನೆಗೆಟಿವ್, ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಬರುತ್ತೆ. H ಪ್ಲಸ್ ಡೈರೆಕ್ಟ್ ಆಗಿ ಇಲ್ಲಿ ಅಟ್ಯಾಚ್ ಆಗುತ್ತೆ, ನೆಗೆಟಿವ್ ಸ್ಯಾಟಿಸ್ಫೈಡ್ ಅಂಡ್ ದಿಸ್ ಬಾಂಡ್ ಇಸ್ ಶಿಫ್ಟೆಡ್ ಹಿಯರ್, ವಿ ಆರ್ ಏಬಲ್ ಟು ಗೆಟ್ ಡಬಲ್ ಬಾಂಡ್. ಸೊ ಅಬ್ಸರ್ವ್ ಮಾಡು, ಸೊ ಇಲ್ಲೇನ್ ಬಂತು CH3, another one is C double bond O, here it contain one H. Name of this compound is called as what? Acetaldehyde. So tautomerism is very important. So shifting of bond correct ಆಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಂಡು directly we can easily write final product. We can take one more example also, that is unsymmetrical alkyne, that is CH3 C triple bond CH. In this unsymmetrical alkyne, addition of water molecule will takes place. So in the presence of same reagent Hg plus 2 and as well as H plus. So same thing, we already know that H plus and as well as OH minus water molecule. So if unsymmetrical alkynes are there, definitely here what happens, addition of OH group will be, otherwise a negative part of the reagent will be attached on those carbon atom which contain less number of carbon atom, we are less number of hydrogen. We already know that is also called as Marconi-Cow rule. So according to Marconi-Cow rule, here OH will be directly attached on this particular carbon. So then finally CH3 C ಇದೆ, ಇಲ್ಲೊಂದು OH ಬರುತ್ತೆ, ಇಲ್ಲಿ ಡಬಲ್ ಬಾಂಡ್. So double bond, thereafter CH2 over. So this enol form is undergo tautomerism. ಗೊತ್ತಿದೆ tautomerism ಹೇಗೆ ಬಾಗುತ್ತೆ ಅಂತೇಳಿ. And finally we are able to get a ketone CH3 ಇದೆ, C double bond O ಬರುತ್ತೆ, ಇಲ್ಲಿ CH3 ಬರುತ್ತೆ. ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? ketone. Unsymmetrical alkyne always gives ketones. Symmetrical alkyne will give aldehyde. So this is another way we can able to prepare aldehydes and as well as ketones. So we can take one more method of preparation of aldehydes and as well as ketones. We can consider by using nitro compounds. So here, if you use CH3, CH2, CH2, NO2. If any nitro compounds are there, nitro compounds are undergo reaction with NaOH, heated with NaOH. So finally, we can able to get the compound as a CH3, CH2, CHO. This is another method. So we can able to get one more component also CH3, CH2, CH. Here one CH3. Here it contain NO2. So when this one should be undergo reaction with NaOH. So when we heat, so then finally CH3, CH2, C double bond or CH3. This is another way preparing aldehydes and as well as ketones. Otherwise, next one more method by using Grignard reagent also we can able to prepare. We can take one example as CH3, CH2, C triple bond N. We already know that nitrile, when this nitrile should be reacts with the Grignard reagent RMgX. So when this one is undergo further hydrolysis, so compulsory we can able to produce CH3, CH2, CHO. This is another method, nitroalkanes. Over. Next, one more important method by using azyl chloride. So here azyl chloride is nothing but RC double bond OCl. So either we can use azyl chloride, otherwise viryl also, benzene containing compounds, ARC double bond OCl. So I'll observe model. When this one is reacts with, so here the reagent what we are going to use. So addition of hydrogen, reduction of hydrogen will takes place in the presence of palladium along with the barium sulfate and sulfur otherwise or boiling xylene. So here boiling xylene is act as a solvent. Boiling xylene is act as a solvent. We already know that this one is considered as a Lindlar's catalyst. ಇದಕ್ಕೆ Lindlar's catalyst ಅಂತ consider ಮಾಡ್ತಾರೆ. So normally whatever the azyl chlorides are there, RC double bond OCl, azyl chloride ಎಲ್ಲಾದ್ರೂ ಕೂಡ reduction ಆದರೆ in the presence of the same thing hydrogen with palladium and BaSO4 here along with boiling xylene. So finally what happens, H and Cl both are combined together to form an HCl and finally one more component RC double bond OCl ಇದೆ RC double bond OH ಬರುತ್ತೆ. So name of this compound is called as what? Aldehyde. ಇದಕ್ಕೆ aldehyde ಅಂತ consider ಮಾಡ್ತೀವಿ. So the name of this particular reaction is called as, I think you already know that, Rosenmund reaction. So the Rosenmund reaction is used to convert azyl chloride into what? Aldehydes. So and one more special character is there actually. So why we are going to use BaSO4 and what is the reason why we are using xylene also? So normally we know that this Lindlar's catalyst. So Lindlar's catalyst always converts a triple bond into a double bond. We already know that Lindler-Kestel is used to convert a triple bond into a double bond. That one is undergo reduction. Otherwise, normally here it contains palladium. This palladium is act as a strong reducing agent. ಈ ಸ್ಟ್ರಾಂಗ್ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ಏನ್ ಮಾಡುತ್ತೆ, ತ್ರಿಬಲ್ ಬಾಂಡ್ ಅನ್ನ ಡಬಲ್ ಬಾಂಡ್ ಕನ್ವರ್ಟ್ ಮಾಡುತ್ತೆ. ದಟ್ಸ್ ವೈ ಸೊ ಫರ್ದರ್ ಎಲ್ಲರೂ ಕೂಡ ಕಂಟಿನ್ಯೂ ಮಾಡಿದ್ರೆ ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ, ಕಂಪ್ಲೀಟ್ ರಿಡಕ್ಷನ್ ಆಗಿ. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಇನ್ನೂ ಒಂದು ನಾವ್ ಹೇಳ್ಬೇಕಂತಂದ್ರೆ ವಿ ಆರ್ ಏಬಲ್ ಟು ಗೆಟ್ ಆಲ್ಡಿಹೈಡ್ ಆಲ್ಸೋ. ದಿಸ್ ಆಲ್ಡಿಹೈಡ್ ಈಸ್ ಆಲ್ಸೋ ಅಂಡರ್ಗೋ ಫರ್ದರ್ ರಿಡಕ್ಷನ್. ಮೇ ಬಿ ಪಾಸಿಬಿಲಿಟೀಸ್ ಆದ್ರೆ ವಿ ಕ್ಯಾನ್ ಏಬಲ್ ಟು ಗೆಟ್ ಅನ್ ಆಲ್ಕೋಹಾಲ್. ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡ್ಕೋ, ಲಿಂಡ್ಲರ್ ಕೆಟ್ಲಿಸ್ ಇಂದು ಫಸ್ಟ್ ಕ್ಯಾರೆಕ್ಟರ್ ಏನು, ಟ್ರಿಬಲ್ ಬಾಂಡ್ ಅಥವಾ ಡಬಲ್ ಬಾಂಡ್ ಶುಡ್ ಬಿ ಕನ್ವರ್ಟೆಡ್ ಇನ್ ಸಿಂಗಲ್ ಬಾಂಡ್. ದೇ ಅಂಡರ್ಗೋ ರಿಡಕ್ಷನ್. ಅಂಡ್ ಒನ್ ಮೋರ್ ಥಿಂಗ್, so maybe possibilities are there. Palladium is undergo further reduction, that is act as a powerful reducing agent. It converts aldehyde into an alcohol. ಅದಕ್ಕೆ ಏನ್ ಮಾಡ್ತೀವಿ, here we can use barium sulfate. This barium sulfate is act as a poison for palladium. ಪಾಯ್ಸನ್ ಫಾರ್ ಪೆಲ್ಲಾಡಿಯಂ. ಸೊ ಈ ಪೆಲ್ಲಾಡಿಯಂ ಇನ್ ಕೆಲಸ ಏನು ಅಂದ್ರೆ ರಿಡಕ್ಷನ್ ಮಾಡೋದು. ಅರ್ಥ ಆಗ್ತಿದೆಯಲ್ವಾ? ಈ ಬೇರಿಯಂ ಸಲ್ಫೇಟ್ ಏನ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ ಆಲ್ಡಿಹೈಡ್ ಆಗಿರೋ ಕಾಂಪೋನೆಂಟ್ ನ ಆಲ್ಡಿಹೈಡ್ ಆಗಿ ಉಳಿಸುತ್ತೆ. ಸೊ ಅದನ್ನ ಫರ್ದರ್ ಏನ್ ಮಾಡೋದಿಲ್ಲ, ಆಲ್ಕೋಹಾಲ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡಕ್ ಬಿಡೋದಿಲ್ಲ. ದಟ್ಸ್ ವೈ ಇಟ್ ಇಸ್ ಯೂಸ್ಡ್ ಆಸ್ ಎ ಪಾಯ್ಸನ್ ಫಾರ್ ಪೆಲ್ಲಾಡಿಯಂ. ಅಂಡ್ ಒನ್ ಮೋರ್ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ ಇಸ್ ವಿ ಆರ್ ಯೂಸಿಂಗ್ xylene ಆಲ್ಸೋ. ಸೊ ವಾಟ್ ಇಸ್ ದ ಯೂಸ್ ಆಫ್ xylene? ವಿ ಆಲ್ರೆಡಿ ನೋ ದಟ್ ಹೈಡ್ರೋಜನ್ ಏನಿದೆ, ಎಕ್ಸಸ್ ಆಫ್ ಹೈಡ್ರೋಜನ್ ಇಸ್ ಕಂಪ್ಲೀಟ್ಲಿ ಕನ್ಸ್ಯೂಮ್ಡ್. ನೆನ್ಪಿಡ್ಕೊಂಡಿದ್ದೆ, ಕಂಪ್ಲೀಟ್ಲಿ ಕನ್ಸ್ಯೂಮ್ಡ್ ಬೈ ವಾಟ್, xylene. ಎಕ್ಸಸ್ ಆಫ್ ಹೈಡ್ರೋಜನ್ ಫರ್ದರ್ ರಿಡಕ್ಷನ್ ಆಗೋದನ್ನ ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿಬಿಡುತ್ತೆ. ಈಗ ವಿ ಕ್ಯಾನ್ ಟೇಕ್ ಒನ್ ಮೋರ್ ಎಕ್ಸಾಂಪಲ್. ಈಗ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ನೋಡು, CH3 CH2 CH ಡಬಲ್ ಬಾಂಡ್ CH C ಡಬಲ್ ಬಾಂಡ್ OCl. ಏನಪ್ಪ ಈ ತರ ಒಂದು ಕಾಂಪೋನೆಂಟ್ ಇದೆ. ವೆನ್ ವಿ ಆರ್ ಯೂಸಿಂಗ್ ದ ಸೇಮ್ ಲಿಂಡ್ಲರ್ ಕೆಟಲಿಸ್ಟ್, ಇಟ್ ಈಸ್ ಅ ಪೆಲ್ಲಾಡಿಯಂ ವಿತ್ BaSO4 ಅಂಡ್ ಆಸ್ ವೆಲ್ ಆಸ್ ಬಾಯ್ಲಿಂಗ್ xylene ಯೂಸ್ ಮಾಡಿದ್ರೆ ನೋಡು, ನಾವು ಈಗಿನ ಕೂಡ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಲಿಂಡಸ್ ಕೆಟ್ಲಿಸ್ಟ್ ಕೆಲಸ ಏನಪ್ಪ, ಡಬಲ್ ಬಾಂಡ್ ಶುಡ್ ಬಿ ಕನ್ವರ್ಟ್ ಇಂಟು ವಾಟ್, ಸಿಂಗಲ್ ಬಾಂಡ್. ಅಂಡ್ ಒನ್ ಮೋರ್ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ ಇಸ್ ಅಸೈಲ್ ಕ್ಲೋರೈಡ್ ಶುಡ್ ಬಿ ಕನ್ವರ್ಟ್ ಇಂಟು ವಾಟ್, ಆಲ್ಡಿಹೈಡ್. ಸೊ ಇದನ್ನ ಏನ್ ಮಾಡುತ್ತೆ, ದಿಸ್ ಈಸ್ ಕನ್ವರ್ಟ್ ಇಂಟು ವಾಟ್, C ಡಬಲ್ ಬಾಂಡ್ OH. ಸೊ ಇದನ್ನ ಏನ್ ಕನ್ವರ್ಟ್ ಮಾಡುತ್ತೆ, ದಿಸ್ ಶುಡ್ ಬಿ ಕನ್ವರ್ಟ್ ಇಂಟು ಎ ಸಿಂಗಲ್ ಬಾಂಡ್. CH2 single bond CH2. This is a use of a Lindler catalyst. This is a one more method we can able to use for the preparation of aldehydes. Otherwise, the same catalyst we can use for the preparation of a benzaldehyde also, C double bond OCl. So here, when this one is reacts with the palladium and as well as BaSO4 along with the boiling xylene, same catalyst na use ಮಾಡಿ. C double bond OH benzaldehyde ಬರುತ್ತೆ. So next, move on to one more reaction, Stephan reduction. Let's move on to Stephan reductions. In Stephan reduction, normally this is used to convert a nitrile into an aldehyde. Stephan reduction ಕೂಡ ಅಷ್ಟೇ compulsory we are using so the function group as a cyanide. Cyanide should be converted into what, aldehyde. So let's discuss. So what are the important reagents we are using to convert nitrile into what, an aldehyde, by using what, a Stephan reduction. So here the reagent what we are going to observe, a strong reducing agent, that is stannous chloride and further hydrolysis. If you observe carefully, stannous chloride, that is act as a strong reducing agent. ಸೊ ಹೇಗೆ ಕೆಲಸ ಮಾಡುತ್ತೆ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ನೋಡು. C triple bond N ಏನಿದೆ, ಸೊ ಅಡಿಷನ್ ಆಫ್ ಹೈಡ್ರೋಜನ್ ವಿಲ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್. ಸೊ ಇಲ್ಲಿ ಏನ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ಕಂಪಲ್ಸರಿ stannous chloride in the presence of an HCl. So addition of hydrogen will take place in the presence of stannous chloride. We can able to get a CH double bond NH. So addition of HCl will takes place. So observe ಮಾಡಪ್ಪ, When this one is undergo further hydrolysis. So finally we are able to get CHO. ಅಂದ್ರೆ ಜಸ್ಟ್ ನೈಟ್ರೈಲ್ ಗ್ರೂಪ್ CHO ಆಗಿ ಹೇಗೆ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳಿದೀನಿ ಅಷ್ಟೇ. Cyanide, so addition of hydrogen will takes place in the presence of a stannous chloride and as well as HCl. Stannous chloride and as well as HCl. Then finally, on further hydrolysis, we can able to get an aldehyde. ಇದು ಆಲ್ಡಿಹೈಡ್ ಬರುತ್ತೆ. ನಿನಗೆ ಅದು ಮೈಂಡ್ ಅಲ್ಲಿ ಫಿಕ್ಸ್ ಆಗಿಬೇಕು. Cyanide should be converted into what? Aldehyde in the presence of stannous chloride. That is called as what? Rosenmund reduction. So another one, the same selective reduction will be takes place. Selective reduction of nitrite. So here why we are using the selective reduction of a nitrile? So compulsory for selective reduction of a nitrile, we can use a special reagent. So that is dibol. We consider so dibol is nothing but diisobutyl aluminum hydride. So dibol H, if you consider dibol H, so it is act as a selective reducing agent. What is the reason behind that? Why it is act as a selective reducing agent? Explanation is very simple. So it easily converts a nitrile group into an aldehyde. That is one thing. But it unable to convert, otherwise it cannot disturb triple bond and as well as any double bonds are present here. So it unable to convert triple bond, otherwise a double bond, but it can able to convert cyanide into what? An aldehyde. So direct explanation is there actually. So you know CH3, CH2, C triple bond N, and this one should be reacts with dibol. And further hydrolysis. So compulsory we can able to get the component as CH3, CH2, CHO. ಸೊ ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಪ್ಪ, ಈಗಿನ ಕೂಡ ಹೇಳಿದೆ ಡೈಬಾಲ್ ಹೆಚ್ ಏನ್ ಮಾಡಲ್ಲ ಅಂತ ಹೇಳಿದ್ವಿ ನಾವು, ಡಬಲ್ ಬಾಂಡ್ ಅಥವಾ ಟ್ರಿಪಲ್ ಬಾಂಡ್ ಏನ್ ಕೆಲಸನೂ ಮಾಡಲ್ಲ ಅಂತ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ವಿ ಕ್ಯಾನ್ ಕನ್ಸಿಡರ್ ಒನ್ ಮೋರ್ ಆಲ್ಸೋ CH ಡಬಲ್ ಬಾಂಡ್ CH, single bond CH2, here C triple bond N. So when this one should be reacts with dibol H in the presence of otherwise when this one is further undergo hydrolysis, so finally it is converted into CH3. Here this particular component otherwise double bond cannot undergo reduction. CH3 CH double bond CH, here it contains CH2 CHO. So you observe ಮಾಡಿ ನೋಡೋದಾದ್ರೆ, so normally what happens, dibol it converts only into cyanide into an aldehyde, but it unable to convert double bond into single bond. Reduction will not take place. So next, after this, we can use by using benzyl. By using methyl benzene, otherwise we can use alkyl benzene. ನೋಡಪ್ಪ ಆಲ್ಕೈಲ್ ಬೆನ್ಸಿನ್ ಯೂಸ್ ಮಾಡೋಣ. So already you know that one reaction is called as Attard reaction. So ಈ reaction ಏನ್ ಮಾಡ್ತೀವಿ, same benzene, ಈ benzene which contains CH3. So when this one is undergo reaction with the chromyl chloride, CrO2 Cl2. So chromyl chloride. So then now on further hydrolysis, so we can able to get benzaldehyde. So another one is ಇನ್ನು ಒಂದು ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಎಟಾಡ್ ರಿಯಾಕ್ಷನ್ ಕೊಡ್ತೇವೆ by using chromyl chloride. So thereafter halogenation. Especially here we have to use side chain halogenation. side chain halogenation. So if we consider benzene, so benzene contains side chain as a CH3. So we already know that the same benzene which contain methyl group. So if it is reacts with the chlorine in the presence of anhydrous Cl3 compulsory, so halogen group is directly attached to benzene ring. But here we required a side chain substitution. So that's why here addition of chlorine should be takes place in the presence of sunlight. When side chain substitution will takes place initially, we can able to get benzyl chloride. Benzyl chloride will undergo further halogenation in the presence of sunlight. So again, one more halogen will attach here. Illon Cl ಬರುತ್ತೆ, illon Cl ಬರುತ್ತೆ. So ಇದನ್ನ ಏನ್ ಮಾಡಬೇಕು? It should be reacts with excess amount of NaOH. So excess amount of NaOH ಜೊತೆಗೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ here these two Cls are completely removed by OH group. ಸೊ ಇಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡ್ತಾ ಇದೀನಿ, ಅಬ್ಸರ್ವ್ ಮಾಡು. OH ಗ್ರೂಪ್ ಜೊತೆಗೆ ರಿಯಾಕ್ಟ್ ಆದ್ರೆ ಸೊ ಹಿಯರ್ ಇಟ್ ಕಂಟೈನ್ CH, ಇಲ್ಲೊಂದು OH ಇದೆ, ಇಲ್ಲೊಂದು OH ಇದೆ. ಸೊ ದೆನ್ ಇದನ್ನ ಹೀಟ್ ಮಾಡಿದ್ರೆ we already know that single carbon contain two OH groups are highly unstable. That's why these are undergo dehydration, removal of water molecule will takes place. So finally ಏನ್ ಬರುತ್ತಪ್ಪ? CHO ಬರುತ್ತೆ, benzaldehyde. This is another method, side chain substitution of an halogen. So thereafter reaction with an NaOH, excess amount of an NaOH. So here removal of Cl will takes place. This is another method. So next in the same Friedel-Crafts by using Friedel-Crafts azylation also. Friedel-Crafts azylation ಕೂಡ ಏನ್ ಮಾಡಬಹುದಪ್ಪ? We can use for the preparation of water. Ketones. Here we can consider same benzene. So this benzene should be reacts with azyl chloride, that is CH3, CH, C double bond O Cl in the presence of same thing anhydrous Cl3. ಸೊ ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಒಂದು ಹೈಡ್ರೋಜನ್ ಇದೆ, ಹೈಡ್ರೋಜನ್ ಅಂಡ್ ಆಸ್ ವೆಲ್ ಆಸ್ Cl both are completely removed. So then the component what we are observing, so we already know that this particular group is called as what? An electrophile. This is electrophilic substitution reaction. This electrophile is direct attached to a benzene, and finally the obtained compound is called as acetophenone. This is another way we can able to prepare aldehydes and as well as ketones. And generally we know that benzene is also undergo ozonolysis. Here cyclic compound is also undergo ozonolysis in the presence of zinc and as well as peroxide. So finally we can able to get a C double bond OH, C double bond OH. So be careful. Here what happens, each and every carbon atom contain one hydrogen atom. Observe ಮಾಡಿದ್ಯಾ ಅಂತ ಅನ್ಕೊಂತೀನಿ. ಸೊ ಇಲ್ಲೂ ಕೂಡ ಅಷ್ಟೇ ಓಝೋನ್ ಲ್ಯಾಸಿಸ್ ಆದ್ರೆ ನಮಗೆ ಏನ್ ಬರುತ್ತೆ? ಕಾಂಪೋನೆಂಟ್ ಬರುತ್ತೆ ದಟ್ ಆಲ್ಡಿಹೈಡ್ ವಾಟ್ ವಿ ಆರ್ ಗೆಟಿಂಗ್ ಆಲ್ಡಿಹೈಡ್ ಅದರ್ವೈಸ್ ಅನ್ ಕೀಟೋನ್ಸ್. ಸೊ ಕಂಪಲ್ಸರಿ ದೇ ಕಂಟೈನ್ ಟೂ ಕಾರ್ಬನ್ ಗ್ರೂಪ್ಸ್, cyclic components ಆದ್ರೆ. So open chain compounds are undergo ozone lysis, we are getting two different components, but two different compounds are same components. So but ಏನಾಗುತ್ತೆ, cyclic compounds are undergo ozonolysis, so compulsory we are getting a single component, so which contain maximum number of carbon atoms. If you observe now one more structure also ಇಲ್ಲಿ observe ಮಾಡಪ್ಪ. So this is a cyclobutene. When this one is undergo ozonolysis, ಇದು ozonolysis ಆದ್ರೆ ಏನ್ ಬರುತ್ತಮ್ಮ? So zinc and as well as hydrogen peroxide. ಸೊ ಈ ಓಝೋನ್ಲೈಸಿಸ್ ಆದ್ರೆ ಸೇಮ್ ಥಿಂಗ್ ಇಲ್ಲಿ ಕೂಡ ಅಷ್ಟೇ ಸೇಮ್, ನಾವು ಅವಾಗಲೇ ಡಿಸ್ಕಸ್ ಮಾಡಿದಾಗೆ. ಸೊ ಇಲ್ಲೊಂದು ಆಕ್ಸಿಜನ್ ಅಟ್ಯಾಚ್ ಆಗುತ್ತೆ. So breaking of bond will take place here also. So the final component what we are observing, same. ಸೊ ಎಲ್ಲಿ ಡಬಲ್ ಬಾಂಡ್ ಇತ್ತು ಅಲ್ಲಿ ಏನ್ ಅಟ್ಯಾಚ್ ಆಗಿರುತ್ತೆ, ಆಕ್ಸಿಜನ್ ಅಟ್ಯಾಚ್ ಆಗಿರುತ್ತೆ. ಸೊ ಇಲ್ಲೊಂದು ಹೈಡ್ರೋಜನ್ ಇದೆ, ಹಿಯರ್ ಆಲ್ಸೋ ಇಟ್ ಕಂಟೈನ್ ಒನ್ ಹೈಡ್ರೋಜನ್. ಸೊ ಹಿಯರ್ ಒನ್ ಹೈಡ್ರೋಜನ್, ಹಿಯರ್ ಇಟ್ ಕಂಟೈನ್ ಡಬಲ್ ಬಾಂಡ್ ಓ. ಇಲ್ಲೊಂದು ಹೈಡ್ರೋಜನ್ ಇದೆ, ಇಲ್ಲಿ ಡಬಲ್ ಬಾಂಡ್ ಓ ಇದೆ. ಸೈಕ್ಲಿಕ್ ಕಾಂಪೋನೆಂಟ್ ಎಲ್ಲರೂ ಕೂಡ ಓಝೋನ್ ಲೈಸಿಸ್ ಆದ್ರೆ ವಿ ಕ್ಯಾನ್ ಏಬಲ್ ಟು ಗೆಟ್ ಎ ಸಿಂಗಲ್ ಪ್ರಾಡಕ್ಟ್. ನೆಕ್ಸ್ಟ್, by dry distillation of calcium formate, either we can consider calcium formate or dry distillation of calcium acetate also. If we consider calcium formate, this is calcium O C double bond O. This is calcium formate. When this one is undergo dry distillation, so in dry distillation, what happens? So it removal of calcium carbonate will takes place. So how the calcium carbonate is completely removed? That is CaCO3. So and remaining part is HC double bond OH. So nenpeduko. So when dry distillation of calcium formate will takes place, so compulsory what happens? It removes calcium carbonate. The remaining part is acetate. ಅದೇ ಕ್ಯಾಲ್ಸಿಯಂ ಅಸಿಟೇಟ್ ತಗೋಣ ಈಗ. ಸೊ ದಿಸ್ ಇಸ್ ಕ್ಯಾಲ್ಸಿಯಂ. ಸೊ ದಿಸ್ ಒನ್ ಈಸ್ ಸಿ ಡಬಲ್ ಬಾಂಡ್ ಓ. ಇಲ್ಲೇನ್ ಬರುತ್ತೆ CH3. Calcium acetate. Here Ca. Here O. Here C double bond O CH3. This one is acetate. So another one is a C double bond O CH3. So here also when this one is undergo dry distillation. ಅಬ್ಸರ್ವ್ ಮಾಡಿ ನೋಡು, ಇಲ್ಲೂ ಕೂಡ ಅಷ್ಟೇ CaCO3 ರಿಮೂವ್ ಆಗುತ್ತೆ. ದಿಸ್ ಒನ್ ಈಸ್ CO Ca and here CaCO3. ರಿಮೈನಿಂಗ್ ಪಾರ್ಟ್ ವಾಟ್ ವಿ ಆರ್ ಅಬ್ಸರ್ವಿಂಗ್ CH3 C ಡಬಲ್ ಬಾಂಡ್ ಓ CH3. ಹೀಟ್ ಮಾಡಿದ್ರೆ CH3 C ಡಬಲ್ ಬಾಂಡ್ ಓ CH3 ಆಗುತ್ತೆ. ಸೊ ದಿಸ್ ಒನ್ ಇಸ್ CH3 C ಡಬಲ್ ಬಾಂಡ್ ಓ CH3. ಸೊ ನೇಮ್ ಆಫ್ ದಿಸ್ ಕಾಂಪೌಂಡ್ ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ನೋಡು, CH3 C ಡಬಲ್ ಬಾಂಡ್ ಓ CH3 ಬರುತ್ತೆ. ಸೊ ನೇಮ್ ಆಫ್ ದಿಸ್ ಕಾಂಪೌಂಡ್ ಇಸ್ ಕಾಲ್ಡ್ as what? ಅಸಿಟೋನ್. ಸೊ ಡೈರೆಕ್ಟ್ ಅಂಡ ಇನ್ನೊಂದು ಏನ್ ಬರ್ಬೇಕು ಅಂದ್ರೆ, ಸೊ ಒಂದ್ಸತಿ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳಿದಾನೆ ಯಾವ ರೀತಿ, ಡ್ರೈ ಡಿಸ್ಟಿಲೇಷನ್ ಆಫ್ ಬೋತ್ ಕ್ಯಾಲ್ಸಿಯಂ ಫಾರ್ಮೇಟ್ and calcium acetate. So what is the product we can able to get? So we can take here calcium formate is nothing but a Ca, here C double bond O OCH3. Wait a minute. So here you can consider calcium, here O C double bond O, here CH3. So here it contain O C double bond O CH3. So thereafter plus this should be reacts with the calcium. Here it contains C double bond O. Hydrogen. Here it O C double bond O H. So when this one is undergo dry distillation, CaCO3. CaCO3. So finally we can able to get to two same product CH3 C double bond OH. Another one is plus CH3 C double bond OH. So by the removal of 2 moles of calcium carbonate. So that means we can able to get 2 moles of acetaldehyde, 2 moles of water, acetaldehyde. These are all some of the important preparations. So what we are going to use. So next, move on to physical properties. So let's move on to the physical property. Here, physical property, we already know that most of them are liquid. Otherwise, we can consider lower aldehydes. So lower aldehydes or are ketones. Lower ketones are, most of them are liquid. So higher aldehydes and ketones. Higher aldehyde and ketones are considered as what? Salts. And one more important thing is when it comes under solubility, most important thing. So here carbonyl group, due to this particular polarity, CO here minus and as well as plus. This particular component having a polarity. So due to this polarity, what happens? They can easily form hydrogen bonding with water. Bonding with the water. So this polarity maximum in C double bond OH rather than CH3, C double bond O, CH3. So this one is polarity will be maximum here. So polarity will be less here. So that's why when it comes to aldehyde and as well as ketones, the ketones will be least soluble in water compared to what? Aldehyde, because so they can easily form hydrogen bonding with water due to the presence of water, O minus. So and one more. So here if you use a CH3, CH2, CH2, C double bond OH. So here this one is considered as a non-polar part. This non-polar part increases, solubility decreases. Solubility decreases. That is also more important thing. And if you consider melting point and as well as boiling point, melting point and as well as boiling point are directly proportional to molecular mass. If molecular mass increases, melting point and boiling point also increases. But due to dipole-dipole interaction, aldehydes and ketones have a little bit higher melting point and as well as boiling point compared to the corresponding hydrocarbons. Adu kudana gothirli. So in next class, definitely we'll discuss about chemical properties of aldehydes and as well as ketones. Right? So thank you very much.